start a new module, Part F, Merge Sort Part 1. Starting from today, because we will have our midterm at the end of this month. So I want to do some review for you. So starting from today, in each lecture or each class, at the beginning part, I want to do some review problems, answer questions from homework 1, comprehension questions, and quizzes. And I use that opportunity to prepare you for midterm. So today we will have the first part, results on some questions from homework 1, part 1. So for homework 1, I will do 2 parts. Part 1, part 2, this class and the next class. Yeah. After that, then I will look at some of the questions in comprehension questions. After that, I will look at some of the questions in quiz number 3. Then you need to work on your midterm test. All right, so let's start. The first question, homework question number 2, this one. This is a pretty easy one. And for each question, I did some statistics. How many students miss this question? And this one, 13%. 13%. So that's not very high. But this one, I want to only explain one thing. For those students who missed this question, I'd like you to pay attention to non-negative m and n. We say non-negative, that means there is a possibility m equals 0 and n also equal to 0, right? Then when you look at the GCD, both 0 does not exist. Based on our definition, does not exist. So in my video, I explained this part. Some students said it's infinity. Although you can understand in that way, but we don't want to write in that way, right? So we don't want to write it out. So this equals infinity. So that's not good. For mathematicians, so they don't like to see things like this. So that's why I try to avoid writing that way. But when you understand it, you can understand in that way. That is okay. All right. So that's question number 2. The next one, question number 3. This one, quite some. So the missing rate here, 30%. So that's, not very low, 30%. So the reason, so here I want to explain the reason. So those students who missed this question, so they did not find the rule. So here I want to check your understanding on the structure of a complete binary tree, a complete. Can you imagine, so in your mind, or you draw on a scratch paper, complete binary tree, okay? Complete binary tree, So when you draw a binary tree, level by level, all the levels are full. All the levels are full, right? So it cannot be, like this. This is not complete binary tree. The bottom level is not full. So for this case, you need to, add all the possible nodes at the bottom level. Okay? So when you have that structure, can you calculate the total number of nodes in a complete binary tree? Right? So let's say we start from level 0. Okay? Yeah. The root level, so usually we like to use level 0. Because if we use this number, then the number of nodes 2 to the 0th power. Okay? So the same thing. The level number, exponent number, they're the same. Yeah. Then level 1, the number of nodes 2 to the 1st. So level 2, the number of nodes 2 squared, and so on. Right? Yeah. All right. So now, so let's look. Okay. Yeah. Look at the the lowest level. Yeah. If we use k minus 1, how about that? K minus 1. K minus 1 is total k levels because we count from 0. Total k levels counting from 0. So then the number of nodes 2 to the k minus 1. Okay? So, all right. Now let's add all these numbers. Okay? Yeah. How to calculate this number? How to calculate this number? Okay? So this is a geometric series. Geometric series. Okay? Geometric series. Okay? The formula, yeah. So I hope you know the formula. Right? Yeah. Yeah. All right. The first term, yeah, so here, the first term, all right, so 1, all right, yeah. Common ratio, yeah, because when you go to this term, to the next term, so you multiply some, common constant number, yeah, all right, yeah. 2, that's 2, yeah. 2, all right. How many total terms? Okay, all right, yeah. K terms. Counting from 0, K terms, yeah. So minus 1, all right. So that common ratio number 2, minus 1, okay? So whatever, yeah, the formula is that. So try to find that formula. So if you are not familiar with this formula, try to find that formula. But after simplification, we have 2 to the k minus 1. All right, so the total number has this format. Okay, power of 2 minus 1. Power of 2 minus 1. Yeah. Check all these 4 numbers. Which one has this form? Power of 2 minus 1. Okay, you will see option C, not option D. So many students give me option D. Okay, or B, yeah. So those students probably, they guess a little bit, they just guess, yeah, 30%, yeah. But you need to know, so this is the background. Yeah, so this is the form you use to check it. Yeah. Complete binary tree structure. Yeah. All right, so that's question number 3. Next question, question number 10. I already explained this question in my video, one of my videos. I saw some of the students studied those videos very well. Yeah, I can see that. So in their homework 1, in their work, really, good work. Yeah. So 80-something above. 80-something above. Yeah. So really good result. Yeah. I saw many like that. Yeah. All right. So this one, 13%. That's pretty good. Yeah. So many students got this one. Yeah. Only 13% missed this one. Yeah. All right. So the growth function, remember, remember, I mentioned that we have the result in class little o of n to the d, right? Any positive d. So this d, we only need positive d, greater than 0. Okay, so this small number satisfies that condition. Okay, so that means over long run, yeah, asymptotic notation, we look at the long term, so not short term. Yeah. So for very big n numbers, so log of n cannot compete with power function, n to the dth power. Cannot compete. Yeah. All right. So anyway, so here I try to use this really small number. You know, the reason I use this number, I try to create a false intuition. Yeah. I try to trick you, you know, because for many of us, when we work on some problems, we make our decisions based on intuition a lot. Sometimes our intuitions may not be correct, may be false. So here I try to create something to, you know, lead you to get a false intuition. So this is one. Okay, false intuition. Yeah. So if you choose this one, it's false. Okay. All right. Yeah. Okay. Yeah. But I put this one to compare with the next one, because the next question very close to this one. So I use these two back to back to do some comparison. Yeah. So this one, number 12, you can see this case, I compare these two expressions on concrete numbers. Yeah. We know for a long run, the second one beats the first one. But here, I want you to try on a specific big number. And if you can determine which one is greater. Yeah, so you need to do some calculation. But the result, let's see the result. 22% miss it. 22%. Yeah. Not very bad. 22%. 2/9. Yeah. Approximately 2/9. Yeah. So among 9 students, two of them missed this question. 2/9. Yeah. All right. So, but here, so let me show those 22% students. Yeah. For the first expression, that's easy. The same base, right? So this expression, we just take away that base part. We only keep the exponent part. So 10 to the 106 power. Okay? Yeah. So that's the first number. The second one, a little harder. Yeah. I saw some students did calculation on their paper. You know, many of them not correct. Yeah. So here, let me do that to show you the detail. Yeah. Hope you can get this part. Yeah. All right. So, all right. So I do not copy. So I just write directly. All right. Let me plug in 3 levels. Yeah. I try to make it a little more complicated and see if you can handle that. All right. This exponent number, very small, I like to use 10 to the -6th power. How about that? Yeah. In this way, so we just work on, you know, properties of exponential functions. Properties of exponential functions. Yeah. First, the first property, yeah, the exponent part should be the product of these two numbers. How about that? Two numbers, yeah. Whatever those two numbers are, we do multiplication. Product of those two numbers. Yeah. Let's simplify it. 10 to the 10, same base. That's good. Same base. 106 minus 6. right? How about that? Okay, all right. So then we simplified another time, 10 to the 100. At the end, let us compare these two numbers. Two numbers, okay, all right. So same base, we only compare exponent numbers. How about that? One side, only 106. The other side, 10 to the 100th power. How much is the difference? Look at that. How big is the difference? Huge difference. Because you know, this number is really big, right? So that's the exponent number. So big, right? Yeah. You know, easily beat that number. Okay? Although you see this expression looks very small, but when we plug in this concrete number, you will see that number is huge. Okay? Yeah. All right. So I hope you can do algebra of this kind. Algebra. We need that. You need to have that basic algebra skill for this class to do well for this whole class. Okay? All right, so let's move to the next question, number 15. Yeah, so this one. I gave you hint in one of my videos, but still many students miss this one. 39%. Close to 40%. Think about that, close to 40%. Okay? Every 10 students, there are 4 miss this question. Okay? So when I talk about miss, if you only miss 1 point, yeah. So each question, 4 points. Okay? Yeah. Each question, 4 points. Yeah. No matter it's an easy question or hard question, 4 points. Okay? Yeah. Okay. So, but I give a lot of partial credit. So based on your answer, how much close to the real answer, so usually I give some partial credit. Okay, yeah, so here, yeah, some student only lost 1 point, yeah, because some student gave me the answer, 168. This is just one away from the real answer, 167. In that case, I take away 1 point. Okay, yeah, partial credit, yeah. All right. Now, let me explain this question. Yeah, so it's not that hard. Okay? Yeah, because after you understand my hint, then it may not be that hard. Yeah, all right. But I saw many students did this way. Okay, did this way. All right. First, 172. Okay, so find top 5, right? Find the top maximum element. In that case, we need to use 171, right? Yeah, a minus 1. Yeah. Then let's do another round. After we remove the biggest one, there are 171 elements left. Then we find the second largest. Okay? So then we need 170, and we do this 5 times. Then what you get is not among top 5, you get the fifth the largest. Yeah, even this is not the best way, because you don't need that many comparisons, right? Yeah, for top 5 we can use much fewer comparisons than that. We don't need that many. Yeah, too many. Yeah, so several students did in this way. Yeah, all right. Here, I designed this question to let you practice elimination method. So this is a very good question using that, practicing that elimination method. Elimination method. Okay, yeah, all right. Top 5, look at top 5. Top 5, that means we need to eliminate 167 elements. Okay? If we can eliminate using using comparisons, but how to do comparisons? Any comparisons, if we can eliminate 167 elements, the remaining 5, any of the remaining 5 must be in top 5, right? Yeah. Okay. So that's the way we view this question. Yeah. Now to do the elimination. Okay. All right. You can do random elimination. How about that? Random comparison. How about that? Because the way to do elimination may not be that important. Yeah. So here. Yeah. But in order to convince you, yeah, when I do elimination, I try to arrange those elements in an organized way so that I can see, yeah, after I eliminate this many, I'm convinced I get an element among top 5. So I also need to do that. I need to convince myself. I need to make sure the way I'm doing is correct. All right, so I will do in this way. Okay, all right. Just like, this way, actually, several students thinking it's correct. Yeah. So we divide it into 2 parts. Yeah. Yeah. This part, 4 elements. Only 4. Yeah. This big subarray, 168. Yeah. So that's the reason some of the students gave me 168 comparison. Yeah. All right. But you missed only a small bit. Yeah. But after you get this 168 subarray, you find the largest one. Okay? Yeah. Find the largest one in this part. Okay? In this part. Yeah. You need 167 comparison. N minus 1. N minus 1. Okay? All right. After that, the winner, you get that one. Okay? So that one beats 167 elements. Okay? So that one, yeah. So let me just call it X1. How about that? X1 beats all those 167 elements. Now I claim this one is among top 5. How about that? So this one joined the remaining 4 top 5. Okay? This one among top 5. I claim that. Okay? Yeah. So I think it's correct. Yeah. So you use this way to, also convince yourself. So not just find the solution, but you need to really convince yourself. Because if you can convince yourself, then you can explain it to other people and convince everyone else. Yeah. All right. So that is this question. Right? Number 15. Oh, yeah. By the way, before I move to the next question, I want to talk about the general case. Yeah. I noticed some students gave me some general formula. Yeah, it's good. So if you can, summarize, get a general formula, that's good. So the general formula is, we have an n element array. Okay, yeah. N corresponds to 172. All right. Now we want to find one element among top k element. Top k element. Yeah. The formula, the minimum number of comparisons, the formula to get that, n minus k. Okay, n minus k, that formula. Okay, using the same solution, but we generalize a little bit. Yeah, because you can verify it. when k equals 1, let's find the largest element, right? Largest element, your formula is n minus 1. Yeah, that matches our existing solution. Yeah, so you can see the general case. Yeah. Okay, yeah. All right. Next question. Number 16. Yeah. So this one, I explained this also in a video. 26% of you miss it. 26% of you miss it. Those students who miss this question, first, definitely didn't use my hint in the video, so that's one. Second, so they try to use some formula to calculate it. Yeah. So many students using the formula like this. Yeah. So I don't know, log base to 20, something like that. Okay. Yeah. Ceiling function, a little bit, things like that. Although you get correct answer, but your formula is not correct. No. The formula is not correct. Yeah. Okay. Yeah. Here, because for the binary search tree, when you draw the binary tree, yeah, first you need to draw that binary tree. Yeah? But the bottom level is not full, right? Yeah, 20 elements, the bottom level is not full. Okay, all right. So if you draw, yeah, so let me quickly draw. Yeah. After these levels, this is a complete binary tree. After these levels, how many nodes do we have? 15. 15. Yeah. 1 plus 2 plus 4 plus 8. 15. Yeah. But we have 5 more elements, right? 5 more. So we need to arrange 5 more at the bottom, somewhere. Yeah. Yeah. So it's not important how do we arrange, but we just know there are 5 elements. Okay? Yeah. The exact locations may not be really important. Yeah. We just know these 5 elements are at the bottom. And these 5 elements, that's the number I will ask you here, correspond to the worst case. Because the bottom level, that's the worst case. Yeah. So you just give me that number. Okay? So you just give me that number. Yeah. All right. After you understand this question, now I want to give you an example. Yeah. Now I want to generalize this question a little bit. Yeah. All right. Here, I like to tell you how do I give you questions in midterm test. Yeah. So here I give you some idea. Yeah. For our midterm test questions. Okay. Yeah. Midterm test questions from we have 3 days, October 31st, November the 2nd, 3 days. Okay. Yeah. 25 questions. Total 25 questions. Each question 4 points, just like your homework number 1. The setting exactly like your homework number 1. But you need to complete in 3 days. All the questions are, we're familiar with these questions. So you won't see brand new question. So question related to some of our questions. Now, but here I like to give you an example. How do I modify our existing questions to make the midterm questions? So I use this question as example. This one. All right. Here, look at this. Here, 20 elements, right? Can I change this number? Can I change 20 to another number? Right? I can change. If I change, that's a question, right? But the way to solve it is exactly the same. Yeah. But here, I want to change in a way, you need to really do something. You need to do some work. Okay? All right. Another thing is, think about solving question like this. Do you always need to draw binary tree like this for the binary search? Maybe not. Think about if I give you a big number here. For example, if I just give you 1,000, how do you draw a binary tree with 1,000 nodes? You get lost. I get lost. I couldn't count by myself. You need a huge paper. You cannot keep track of your nodes, right? Nobody can even imagine that. Yeah, nobody can do it. I cannot do it. Yeah. So here we need to solve a question like this without drawing binary tree. Can we do that? Yes, we can. So here I show you an example. Yeah. After I show you this example, you need to prepare to have a similar question in midterm. Okay? Yeah. Get ready for that. All right. I just used this 1,000. Okay? 1,000. So, given 1,000 element array, sort it, right? Sort it so we can apply binary search. When we apply binary search, how many elements in this array correspond to the worst case? That's the question. Okay? Now let's solve it. Because based on our observation on this binary tree, can you see something special? The property special? Yeah, so you can see if we do not look at the bottom level, yeah, this is the bottom level. If we do not look at the bottom level, then the remaining part, it's a complete binary tree, right? Complete binary tree, how many nodes in a complete binary tree? 1 shy of power of 2, right? 1 shy of power of 2. That's the number of nodes for a complete binary tree. That number is important for us. Okay, all right. So let me first use this new way to solve our original question. Then we go to the 1,000 case. Okay, all right. 20, yeah, n equals 20. Okay, all right. First, we need to find that power of 2k minus 1, that one less than this n. How about that? Okay, how about that? Less than that. All right. Or less or equal to. Yeah, so let's include, yeah, if n equals power of 2 minus 1, it's okay. Include it. Okay, yeah. What is the largest k for it? Can we have that? Yeah. 2 to the 4th minus 1 less than 20, right? All right. After you find that, take the difference of these two numbers. Right? 20 minus 2 to the 4th minus 1. That's the answer. If you use this way, you do not need to draw the binary tree. It saves your time to draw the binary tree. Okay? More importantly, when you work on relatively big number like 1,000, then it saves your day. Otherwise, nobody like to do that. Draw that big binary tree. Nobody likes to do that. Yeah. Let's do the practice. Yeah. This time, we want to find the largest k such that 2 to the k minus 1 less than 1,000. How about that? Can you have that k? Right? Yeah. 2 to the 9th, right? K equals, you can test a little bit. Okay? If you want to use calculator, it is fine. Yeah. You can do some experiment. Yeah. So 2 to the 9th minus 1 equals 511. 511. Yeah. All right. Now take the difference. That will give you the answer. Okay. 1,000 minus 1,000. Yeah. not 100. 1000 minus 511. What's that number? 489, right? 400. You give me this answer. You just give me this answer. Okay? Yeah. All right. So in the midterm, it is very likely I give you a similar question, but I use another relatively big number and see if you can get it, because there is no way you can draw the binary tree. Yeah, let's look at if you can get it. Yeah. All right, so we finish part 1, F.1. The second part, we will do it in G.1.